Good morning. My name is Vipul Das, and this is my submission for the Sparks Foundation Internship Program Task 7 titled Stock Market Prediction Using Numerical and Textual Analysis. Since the task offered the freedom to pick my own stock and my own source for the news, I elected to use Tesla, and the news headline data was obtained from a dataset from Kaggle, the link to which is available in the notebook. Broadly, there are 5 parts to this notebook. For part one, I prepare the news headlines from the dataset obtained from Kaggle. The target stock is Tesla, and I filtered the news according to Tesla, ending up with 1929 results. I then converted the data type for the date column to date time and extracted only the year, month, date info from it. Then I grouped the headlines by date and added them to a single record by date. Finally, the date column was converted into the index and sorted according to ascending order. For part 2, I get the stock price history for Tesla using the Y Finance library. Once the history is stored in a variable, the stock split and dividend columns are dropped. And for part 3, I combine the text data and the stock price data with the common factor being date index. All null items are dropped from this data frame. For part 4, in the dataset obtained in 3, sentiment analysis is performed on the text using Vader, which is Valence Aware Dictionary and Sentiment Reasoner. It's a lexicon and rule-based sentiment analysis tool that is specifically attuned to sentiments expressed in social media and works well on texts from other domains. Import the NLTK package and instantize the sentiment intensity analyzer. Then specifically choose the compound sentiment analysis and add the values generated to the data frame. For part 5, we finally get to the model building and predicting. This is a simple line plot of the stock price of the data. Now, for this particular model, since predictions is the end goal and close will be our target variable, we will shift the close column and the compound sentiment column by 1 and create separate columns for these new values while making sure to get rid of any NA values generated. Again, define the targets and the inputs and scale the data in the range of -1 to 1. Scaling is important because machine learning models tend to give more weight to features with bigger values. Scaling will be done with objects that are instantiated from the min-max scaler, one object each for input and target variables. Now, a quick word about the LSTM model that we'll be using for this particular task. Long short-term memory is an artificial recurring neural network architecture used in the field of deep learning. Unlike standard feed-forward social networks, neural networks, LSTM has feedback connections. It can not only process single data points such as images, but also entire sequences of data. For example, LSTM is applicable to tasks such as unsegmented connected handwriting recognition, speech recognition, and anomaly detection in network traffic or intrusion detection systems. In short, this neural network is capable of learning order dependence in sequence generation problems. LSTM inputs are in 3D, which is why the input feature set here is being converted to 3D, is being reshaped to 3D. The meaning of three input dimensions are samples, time steps, and features. After all this, you finally create the actual sequential model, define the layers in batch size, then compile the model, and finally predict on the test set. Since we scaled the data before inputting it into the model, we'll have to unscale the final outputs as well before we can actually plot it for comparison purposes. This is the final plot created to compare the predicted outputs and actual outputs. Blue is the predicted close price, and yellow is the orange is the testing close price. This model isn't an ideal model. The primary problem is that it has been created using only 233 observations. The limiting factor was the news headlines about Tesla. It is unlikely that there would be a piece of news every single day about Tesla. A way to improve this model will be to additionally include news on the electric vehicle industry and battery industry so that more observations could be considered and the model would have a larger variety of inputs to train on. One such location where you could obtain this data would be Refinitiv, but I don't really have a subscription for that, so I'm stuck there. And that is it for task 7. Thank you.